Our goal here is to learn and build a simple IoT device that can monitor the temperature and upload the data to the cloud using Wi-Fi. So we are going to take this a step-by-step approach so we can understand each and every piece. First, we will write a simple program to display a test message using Arduino IDE and load this test program to NodeMCU device. That way we can make sure that the PC can communicate to the NodeMCU and we successfully flash the NodeMCU device. Second, we will read the temperature sensor data and display it on a serial monitor using Arduino IDE. That will make sure that the NodeMCU, the Groove, NodeMCU base shield and the temperature sensor are working together. The third, we will connect the NodeMCU device to the Wi-Fi. And next, we'll set up a ThinkSpeak account. That will make sure that we can upload this data to the cloud. And then we'll upload the data to the cloud and then visualize the data on a simple graph. The complete setup for this IoT node. Let's connect the micro USB cable to NodeMCU. We can verify the NodeMCU is recognized as a USB device and verify the COM port number. It is recognized as COM port 3. Note down the COM port number. Open the Arduino IDE. Make sure we select the correct board manager. In this case, it's a NodeMCU version 1.0. And make sure we set the COM port to number 3 and leave the rest of the others as it is. When you open the Arduino IDE, you can see there are two sections of code that is preloaded onto the IDE. One is a setup and another one is a loop. In the setup is where you put your code that to have run once, and in the loop where you put your code to run repeatedly. So in the setup, let's begin the serial communication with the serial.begin and the bytes per second as a speed how we want to communicate with the PC. Once we set up the serial communication, then we go to the loop and then we set up a delay of 2 seconds because we don't want to display the test message too often. So we set up the delay as 2 seconds and then we'll print a simple message called "this is a test message" on the serial monitor. Let's go ahead and upload this code into NodeMCU by clicking the right arrow button in the IDE. Once the sketch is compiled, it will be uploaded to the NodeMCU. This might take a couple of seconds. So you can see here the progress at which the program is being uploaded. So if you see any error messages here, that means the NodeMCU is not properly configured on the PC, or the proper driver has been not loaded, or the proper COM port number is selected. So make sure you select the right COM port number which is mapped to the NodeMCU. Once it's done uploading, open the serial monitor by going into the Tools menu in the Arduino IDE. You can verify the percentage in the console window to see how far the upload has went. Open the serial monitor and then make sure the protocol bits per second for the serial port is set to 115200. Because that's how we had actually initiated the communication between the NodeMCU and the Arduino. You can see that this test message is being repeated for every 2 seconds. In this video, we wrote a simple program to display a test message using Arduino IDE and then loaded this test program into NodeMCU device.